Hello everyone, welcome back to my channel and this series of JEE advanced questions. Now this question belongs to the topic of double titration, and if you have no idea that what is double titration, you can go into the channel and watch one of my lectures where I've taught it properly about all the aspects of double titration, right? So now let's come back to the concept and the question. The question says we are given the 40 gram NaOH and 106 gram of Na2CO3 and 84 gram of NaHCO3. These three components are given to us and they are dissolved in water and the solution is made 1 liter. That means the final volume is made 1 liter. 20 ml of the stock solution. What we have done, we have taken this 20 ml solution out of this 1 liter solution. So once we have prepared the 1 liter solution by dissolving 40 gram NaOH, 106 gram Na2CO3 and 84 gram NaHCO3, we have taken out 20 ml of this one and we are performing its titration with 1 normal HCl, right? So HCl given to us is 1 normal. Now the question is asking us which of the following statement is correct. So four statements are given. If you look at the four statements, these four statements are basically the three stages of titration, or we can say three different ways we perform the titration. What are those three ways? First way is if we use the phenolphthalein from the beginning. Second way is if we use methyl orange from the beginning. And third way is that methyl orange is used after the first endpoint. So there are three ways in which we perform the double titration. First way, the phenolphthalein is used from the beginning. Second way, methyl orange is used from the beginning. And third way, that methyl orange is used after the first endpoint. Right. So we have to solve the question based upon the given data, and by getting the correct answers, we can easily mark which option is correct. So let's go to the problem and let's see the solution of it. Now we are given the given masses of each component. So what do? We will find the number of moles of NaOH, number of moles of Na2CO3 and number of moles of NaHCO3. So once we have 1 mole of NaOH, 1 mole of Na2CO3 and 1 mole of NaHCO3, we will dissolve these given moles of substances in volume of 1 liter, right? So basically 1 liter of solution has 1 mole of NaOH and 1 mole of Na2CO3 and 1 mole of NaHCO3. So if you have to take out 20 ml of the stock solution, we need to know how much quantity of these components are present in 20 ml. So simple point is there. If 1 liter contains 1 mole of NaOH, then 20 ml contains how many, right? But keep in the mind that volume should be in the liter or ml while comparison. So what do? 20 ml means 20 upon 1000 liter. I can say if I have to convert into liter. So this is equal to what? This is equal to 0.02 liter, right? So 1 liter contains 1 mole of NaOH, then 0.02 liter contain how many? 0.02 moles. Same story is with Na2CO3 and same story is with NaHCO3. That means 20 ml of the stock solution contains 0.02 moles of NaOH, zero point 0.02 moles of Na2CO3 and 0.02 moles of NaHCO3. Now comes the main point. When we start the titration by using the phenolphthalein in the beginning, now we know during the use of phenolphthalein, the titration is occurring at the basic medium, right? The basic medium is the dominating medium of the solution, and titration occurs in that medium. And we know the moment you start adding the titer, titer is what? Titer is the solution which we pour in by using the pipette into the beaker, right? So the beaker solution is basically titrant, this is titrant and this is titer, titre. So we are doing the titration using HCl, right? If you look at the first reaction, NaOH will be consumed first. I'm again repeating, if you have no idea that why these reactions are occurring in this way, you have to go and watch the video of basic understanding of double titration topic. Go through there and then you can again come back to this question and understand it and learn it. Now NaOH plus HCl, we know the first reaction will occur and NaOH is totally neutralized by using the HCl. In the second reaction, again Na2CO3 is consumed by HCl and we get NaHCO3 and NaCl, right? We are given in this 20 ml of stock solution 0.02 moles of NaOH and 0.02 moles of Na2CO3. If you look at the reaction A and B, both the reactions are balanced. In reaction A, The stoichiometric coefficients of both reactants NaOH and HCl are in the ratio of 1 is to 1, right? Same stories with Na2CO3 and and HCl 1 is to 1. That means if 0.02 moles of NaOH are there, how many HCl moles are consumed? The number of moles of HCl consumed are also 0.02. Similarly, in the case of reaction B, zero point zero 0.02 moles of HCl are also consumed because the ratio of stoichiometry is what 1 is to 1. That means how many moles of HCl consumed here? Number of moles of HCl consumed are 0.04. So once we obtain the number of moles, we can easily find the volume because we know molarity is equal to what? Number of moles per unit volume. So number of moles we need to find. We need to find the volume. So volume is number of moles by molarity. Since HCl has n factor 1, HCl has n factor of 1. So its molarity is equal to normality, right? So what do we obtain? We obtain volume as 0.04 only, which is in liters. So in the terms of ml, it will be 40 ml. So if we use phenolphthalein from the beginning, the amount of HCl which is consumed is 40 ml. So we have to check if any option is there. Yes, option A is correct. Next, option B, or we can say next second method of titration, when we use methyl orange from the beginning. When the methyl orange is used from the beginning. In this case, the reaction occurs, that is the first again same reaction, NaOH plus HCl. Again the stoichiometry is 1 is to 1, so amount of HCl consumed is 0.02. Next, Na2CO3 is consumed by HCl, so again 0.02 moles of HCl are consumed. But if you look at the NaHCO3 coefficient, sodium bicarbonate, it is also 1, 1 and 1. That means if 0.02 moles of Na2CO3 are consumed, 0.02 moles of NaHCO3 are produced, right? Third reaction occurs in acidic medium. We know this reaction occurs in acidic medium. Now here, how many moles of NaHCO3 are there? 0.02 moles of NaHCO3 comes from the reaction D, right? The D reaction occurs and NaHCO3 produced here will be reacting here, and the remaining 0.02 moles we have already available in the solution, right? This one, 0.02 moles of NaHCO3 are already present in the solution. Just a second, not this one, right? These 0.02 moles of NaHCO3 are already present in the solution. So that means here we have total of 0.04 moles of NaHCO3. So if you look at this reaction, again this reaction is balanced. Stoichiometry is 1 is to 1. That means how many moles of HCl are consumed? 0.04 here. So total moles of HCl consumed when we use methyl orange from the beginning is zero point zero 0.02 plus 0.02 plus 0.04. So it is 0.08. That means again if you need to find the volume of HCl consumed, it will be 0.08 upon 1, the way we have done above, and it will be 80 ml. So if you use methyl orange from the beginning, the volume of HCl consumed is 80 ml. Option D. Third way is what? When the methyl orange is used after the first endpoint. Now we know after the first endpoint what is remained in the chemical reaction. Among the three given reactants, the three given components, that is NaH, Na2CO3 and NaHCO3, the only component which remains in the reaction after the first endpoint is NaHCO3. So NaHCO3 is obtained in two ways. One, which is already available in the solution, that is 0.02 moles, and second, which is formed during the first endpoint, right? Before we obtain the first endpoint, or we can say during the achievement of first endpoint, the amount of NaHCO3 formed is how much? It is 0.02. So total NaHCO3 is 0.04. That means amount of HCl consumed is also 0.04 moles. That means volume will be equal to what? 40 ml. So when methyl orange is used after the first titration, or we can say after the first endpoint, the amount of HCl consumed is 40 ml. So if you look at here, the option C is correct, right? If we use the methyl orange after the first endpoint, the amount of HCl consumed is 40 ml. So option A, C, and D, these are the three options which are correct. And I hope you understood the concept based problem perfectly. So this is a proper detailed solution. Now if you we can do one more thing, we can also use the concept of gram equivalence. So in one of the problems related to the double titration, I will be using the concept of gram equivalent and will provide you the alternate solution of this problem or similar problem, right? So I hope you understood properly, and stay tuned for the next problem and next concept. Stay happy. Thank you. Goodbye.